Well, hi everybody, my name is Luke Gaydos. I am currently the team lead for the Music and Outreach for Reform. The way I got involved into 3D printing dates back to my senior year of high school. I took a CADing class, a 3D modeling class, which was later a prereq for my engineering problems course. But it was an environment where it got you into this idea of engineering, of seeing a problem and starting to develop and design ideas. And we just so happened to have 3D printers, and that was the primary way that we then brought those ideas to life. The reason I'm interested in Reform is that it really ties in a lot of different things that I'm involved in and passionate about. First and foremost being I'm a materials engineer here at Iowa State. Very interested obviously in materials, into their properties. This is, 3D printing is a form of additive manufacturing. I'm very interested in additive. It also combines in this creative aspect and this musical aspect. The original purpose of Reform, it stands for recyclables for music. We've kind of broadened out since then, but it ties in some of those things. I used to be in drum corps. I was very involved in music in high school. And so it's a great way to tie in both science and music, STEM and arts. And today what I'd like to talk to you about is this 5-step process that we use once we have our recycled PET filament, being able to then take that filament and use a bit of creativity to be able to start and go through this 5-step process of taking our idea, putting it on paper, being able to then draw it up in a CAD software, draw it up in a SolidWorks software or some other 3D modeling software, slicing it and printing it. The first step out of the 5 would be getting that idea down on paper, having a sketchbook. Personally for me, I always have one on me. There's usually one in my backpack, and I keep it as throughout the day. Maybe I'm at home, maybe I'm in class. Sometimes just the weirdest things will pop into your head, and being able to jot those down at any time is a great way in order to remember them, because you don't always remember them, as well as being able to sketch those ideas down. It's one thing to have something in your brain, an image, an idea. It's something entirely different to be able to have that drawn out and then be able to convey that with other folks. The second part in that process is then being able to make some measurements and start putting data down, starting to actually come up with what this object really looks like in terms of scale. Usually for me, I like to use a CADing software. AutoCAD is one that I personally love to use. It's one that I actually learned in high school. And from there I can begin to get schematics, blueprints if you will, things that I can actually begin to understand and really begin to have an idea of what the object looks like. From there, I'm able to use that blueprint in our third step, and that would be modeling it up in SolidWorks. The difference between AutoCAD, like a CAD software, and an actual 3D modeling software is the dimensions, obviously. There's a third dimension. The way you do that in SolidWorks is a little bit different, and it allows you to actually create a printable part later on, which leads us to our fourth step. That fourth step would be taking that file, that SolidWorks file, turning it into what's called an STL file, and from there we can throw it into another software called a slicer. A slicer is what converts an STL file, this 3D image, and turns it into code, something called G-code, that a 3D printer like the Ultimaker behind me would be able to understand. And from there we're able to print it. There's a lot of different settings we can tweak within that slicing software, and by using that software we're able to better tune the print performance of the filament that we use. So as a proof of concept of the printability of this PET filament that we've been able to recycle from plastic bottles, we've been able to print this XYZ cube. You can find these on Thingiverse. One of the interesting aspects of these is that they're usually used to test the printability of a filament, or more so to be able to benchmark a printer and make sure you have it tuned up properly. There's a number of different aspects that you can look at this. The first one and most obvious being what's called the elephant's footing, which is on the bottom of the print. This shows that there might be an issue with the layer height adjustment, how much that print head is moving as it prints the material. It could also be an issue of the flow of the material and how it's extruding out of the nozzle. Some of these things can be addressed in the slicer settings when you go to make the file to then have the 3D printer print. You can also do some adjustments in what's called Z-step. That's just how or the intervals that the printer moves by in order to print the part. One of the big significance of this though is that it proves the concept that you can take a bottle and grind it down, clean it, and extrude it out into filament, which can then be used to print cubes that are honestly about as good of quality for the time being as what I print off of normal, store-bought PLA filament. So the future for being able to correct some of these issues that are with this cube would be obviously looking at the degradation of the material, seeing how it changes as it gets recycled multiple times. Another thing is being able to make sure my printer is actually tuned up properly. Since buying it, I haven't done anything with it.
Thank you.